Today we're going to begin introducing the cybersecurity lifecycle. Focus will be on the analysis portion, but we'll also give a little bit of an overview how it integrates with the overall safety lifecycle. Okay, Courtney, having a little technical difficulty. Slides are not scrolling. Courtney to the rescue. Okay, just a little bit about Exida. We're a global company. You can see we've got a presence around the world. Since we're talking about cybersecurity, these are the main products and service categories. Those that are highlighted in green are the aspects of consulting, tools, certification, training, and professional certification that we get involved in. Just a little bit about myself before we start. Name's Hal Thomas. Spent 10 years in process control, and after that pretty much a process safety engineer for the balance of my career. Over the last 7 years, with the recognition that cybersecurity can have a significant impact on process safety, I've gotten fairly heavily involved. I currently chair the S84, ISA S84 Working Group 9, which is putting together a technical report, second revision for cybersecurity that deals with the safety instrumented system and industrial automated control system associated with that. Today what we hope to do is provide an overall awareness of cybersecurity lifecycle and how it integrates with the process and functional safety life cycles. The functional safety life cycle was really born out of process safety management and that life cycle. Cybersecurity is just another extension of those things. Today the focus is going to be on the analysis phase of the life cycle. In subsequent webinars we'll deal with the design and implement phase, the operate and maintain phase, and today the first three parts we'll be looking at things from a greenfield new project type perspective for those people, companies that are at a brownfield installation and you have not looked at cybersecurity. That's where we look at part 4, how to enter the overall life cycle from a brownfield installation perspective. When considering why industrial automated control system security is important, you've got to recognize that our control systems, they're doing real work out there. And in the safety world, we've always realized that when failures occur, bad things can happen. Now, because of cybersecurity and potential attacks on our systems, even worse things can happen, because now you can look at those kind of attacks as a common mode failure that can take out more than, say, just the safety instrumented system. It can actually create the demand and also eliminate your instrumented protection layers. Potential consequences, you can, depending upon what you do to a facility, you could end up with people getting sick, injured. You could have fatalities depending upon the types of loss of containments that you have. It can result in environmental consequences, production loss, equipment damage, off-spec dangerous product. I did not list loss of proprietary information or intellectual property or privacy, those things certainly are potential consequences, but with regard to an industrial automated control system, those tend to be lesser consequences relative to the kind of consequences that we would look at from a process safety management perspective. When you consider that cybersecurity attack can represent a major type of common mode attack or failure on the entire IACS, depending upon the complexity of the attack, you generally find that when you look at the security level that you need, it needs to be greater than you would typically think of in terms of a safety integrity level for a safety instrumented function. Security levels, you can consider those analogous to safety integrity levels, but they are not the same thing. An example of one attack that occurred, they had a scram at a Browns Ferry Unit 3, and it was because both reactors 3A and 3B recirculation pumps were taken out of commission, and when they went in and did the investigation, they found that the VFD controller malfunctioned, or controllers malfunctioned, and it was because of excessive traffic on the plant Ethernet. This would be an example of a denial of service attack and the kind of thing that one would have to protect so that you can avoid these types of circumstances. Back in 2007, a federal regulation was issued, and it's known around the industry as CFATS, Chemical Facility Anti-Terrorism Standard. And this standard looked at all of security. A lot of the focus was on physical security, but one of the risk-based performance standards that's associated with CFAT addresses cybersecurity, provided some initial guidelines that one needed to address cyber sabotage. Industry has been responding ever since. It started with the S99, ISA S99 group of standards, which now has been merging with the suite of IEC 62443 standards. Those are a suite of standards and technical reports. We'll talk a little bit more about them on the next slide. But recently, in 2010, the last edition of IAC 61508 dealing with safety instrumented systems, it doesn't provide any specific real guidance, but it does indicate that you need to address cybersecurity as part of looking at how much risk reduction you can take credit for. So that's a big change. IEC 61511, which is geared towards the process sector, process industry sector for safety instrumented systems. In the upcoming revision that is, I believe, been approved, not necessarily published yet, but it will should be coming out in 2017. That also, the words there also indicate that you need to address cybersecurity. Recognizing that those two standards provide very, very little in the way of guidance, ISA initiated Technical Report 84.0009, and we are working on that currently working on that, trying to move towards ballot for the second revision this coming fall, and that's the cybersecurity related to the functional safety lifecycle. So a lot of what you're seeing is excerpts from that technical report. Getting back to the IACS 62443 suite of standards and technical reports, you can see that it's a work in progress. There's a number of standards that have been published, but that's actually, I don't want to say the minority, because there's a number of others that have been published but are under review. Some are just in the planning stage, and some are in development. The Volume 1, the 4 Volume 1 series, is supposed to be general. The Volume 2, looking at policies and procedures. 3, looking at systems. And 4, looking at components and geared a little bit more towards equipment manufacturers. Part of the, if you look at 3 of the key items, if you look at 2-1, requirements for an IACS security management system, that deals with requirements from management perspective. 3-2 is looking at risk assessment, which we'll talk a little bit about today because it's part of the analysis phase. And 3-3 is looking at foundational requirements, sort of recognized and generally accepted good engineering practice, and they're trying to relate requirements to security levels that you would want to achieve. This slide shows just conceptually that if you look at the safety life cycle on the left, you can break the life cycle down into major categorizations. You go through an assessment or an analysis phase where you're doing things like the process hazard analysis. You go through a design and implementation phase, and then ultimately you start the plan up and you're in the operate and maintain phase, and there's actually a recycle loop back to the assessment phase, and that would occur as part of the management of functional safety and cybersecurity on the left. On the right-hand side, you got cybersecurity, and all of the cybersecurity activities have got to be done along with your safety life cycle. There's certainly some unique things to cyber that get dealt with just as cyber, but wherever you can leverage an existing work process, you want to leverage that existing work process. An example would be when you go from the design and implement to the operate and maintain phase, there's a requirement within industry regulatory standards to do a pre-startup safety review, PSSR. Well, as contributions to that PSSR, you've got your functional safety stuff that you need to validate, but you also would need to validate the same level of important things associated with cybersecurity, for instance. So it's not total add-on work. You want to integrate your life cycle activities with work processes that you already have in place to the greatest extent possible. The NIST framework is shown just as an example of one mechanism to sort of audit just where your plants are at and how well you've addressed the various life cycle activities. This is a bigger breakdown of the analysis or assessment phase for cybersecurity. Each of the white boxes has inputs, and then you end up with deliverables. But when you go through a project, you're going to define a scope. For us here, we're going to need to identify the system under consideration, do some preliminary design so that you can estimate the cost of the project. There's a requirement in the IACS standards to perform a high-level cybersecurity risk assessment and a detailed cybersecurity risk assessment. Between the two, the system under consideration, that preliminary design should be updated. When you're doing that design, you should be considering potential vulnerabilities based upon recognized and generally accepted good principles to help put together a solid design. After and as part of doing the detailed cyber risk assessment, just like when you're doing a HAZOP, if you're looking at your risk, you're comparing that risk, the likelihood of an initiating event, and the likelihood of the event after you've taken credit for countermeasures, cyber countermeasures, and the potential consequences. What is your risk? Does that match your corporate risk criteria? Is it tolerable? If not, then you're going to have to go back, modify the design, look across the board at how you can lower your risk. If you do, once you've met your risk criteria, then you want to document your requirements. And documenting the requirements, once again, this is an analogy to the functional safety side, where in functional safety you have a safety requirement specification for your various safety instrumented functions and safety instrumented system. Here you need a cybersecurity requirement specification that basically can get turned over to the design team and the operations team so that the what was found during the risk assessment, you can ensure that those things are actually included in the design so that you can achieve the risk reduction that you determined that you needed. The interface between the analysis phase and the design and implement phase, there's a functional safety assessment, and we need a cybersecurity assessment contribution to that to make sure that the work was done. We'll talk about that a little bit later too. Okay, digging into each of the boxes just a little bit more, starting out with scoping out a project. One of the things that's required is to document what corporate policies and practices and procedures are applicable to the project. Also, should be, when you're scoping out the project, should be consider what types of hazards that particular plant could be exposed to, what kind of requirements do you have for remote access, what kind of requirements do you have for physical access security relative to industry guidelines. In some cases, there may need to be vendor contractor access to some things. How's that going to get handled? For reliability, looking at redundant operations. Ultimately, all of these things have an input to what kind of budgets that you're going to create for the project. Identify the system under consideration. Early on, supposed to begin putting together preliminary layouts of architectural drawings. Also want to create an inventory of cyber assets, and we want that to be done as a function of the process or utility areas. Reason for that is different process areas or different utility areas may have different hazards associated with them, and ultimately may result in different security levels. It will have an impact on just how you architect or how you segment the system that's being designed. Want to also look at, once you know what policies and procedures, you want to compare those to what are the policy and procedure expectations from a RAGAGEP, recognized and generally good accepted practice perspective, because as you saw from the suite of IAC 62443 standards, this is an evolving area. So some of the policies and procedures of the past may need to be updated if you find vulnerabilities associated with what you've been doing versus what is good practice today. And doing those first two bullet points, it really, if you're going to cost out and estimate a budget cost for your project, you need a means to do that, and without an inventory of cyber assets, it's very, very difficult to come up with a legitimate budget. Early on, you want to do a high-level cyber risk assessment. This is a requirement within the IAC 62443 standards. It can be used to help establish the scope for new projects. It's intended to essentially take about a day. Once you've done this a few times, it could actually take less. What we're doing is coming up with looking at classes of assets as a function of where they are in the process. We're not going to look at, say, all the controllers in a particular area, because all we really need to worry about are what is the worst case consequence if that asset were compromised for that area. So if you've got multiple controllers in the same process area and you're just looking at the worst case consequence with a likelihood probability of 1, that can help you establish the security level target for that type of device in that process area or utility area. During the high-level risk assessment, you can also take a look at, put a stab at defining the expected response should a device type be compromised. So an example of a worksheet for a high-level risk assessment might look like this. We've taken 3 different areas, 2 process areas, 1 utility area. The cyber asset type in all 3 cases was a controller. For the reaction area, the consequence is a potential runaway reaction. The way the scope of the project was developed was that the rupture disk for that reactor was either eliminated or it had certain sizing cases eliminated due to design and implementation of a high-integrity pressure protection system, a HIPS. So if that HIPS had a demand on it, that runaway reaction, and it failed, there are the potential for rupture of the reactor and multiple fatalities. That was given a criticality or a severity of a 5. They decided they were going to have a security level target of 4, looked at what's the ease of propagation from there. Not particularly easy to propagate from the controller, but by the time you get to the controller, oftentimes it's too late. In this case, recommended response, if it was compromised, was shut down the process. In the case of the compressor, the consequences were still severe but less. There, the recommended response, if compromised, was shut down or implement alternate means of protection until fixed. When looking at the controller and cooling water chemicals, there's some potential for long-term corrosion. It's not going to be immediate. There, the security level felt didn't need to be any better than security level 1, and the response was isolate the asset and quarantine until the threat has been removed. So that would be an example of a high-level risk assessment. After that, you want to take the architectural drawings and update those. During that, you're probably also continuing to update the inventory list of cyber assets. It's important to list all the third-party connections, important to document all remote access requirements and countermeasures to prevent being compromised by a cyber attack. You want to segment your architecture into zones and conduits. You're taking that input from the high-level risk assessment to help assign what assets are going to be located in what zone. You're also going to evaluate device cybersecurity configuration rules. The reason for all of this is you can look at these things here as being the analogous, if I were to create an analogy to the process life cycle, getting ready for, say, a HAZOP as part of the PHA, you need process safety information. You need your P&IDs. You need to know what kind of piping specs, pressure, temperature specs that you have. You need to not understand your process chemistry, those kinds of things for a traditional HAZOP. This is the kind of information that you need in order to conduct a detailed level cyber risk assessment. So, like I said, it's analogous to process safety information, but it's specific to the cyber portion of the process hazard analysis. Which brings us into a slide on segmenting the network. When you do segment the networks, you want to employ a defense in depth strategy. Want to slow things down so that you can respond to an attack before it actually totally, you may have a penetration of your system, but it can take some period of time before harm or maximum harm can actually be accomplished. So if you can detect those things, if you have a defense in depth strategy, you can detect and respond before the ultimate consequence is actually achieved. When you segment the network, you're putting together groups of assets into a logical common security requirements. You can also have subzones within zones. For each of the zones, you should be defining your security objectives and the strategy for that zone. And it's very, very important to consider how you're protecting communications between zone to zone through the conduits. This is an example of a zone and conduit diagram. This particular plant broke it into an A, B, and C zone. Firewall between each of those zones and the enterprise. If there's going to be communication from zone C to zone A, basically it's going to have to go up through the enterprise and down into the other zone. So in each case, that would be going through a firewall. As I said, all of that information, the zoning conduit drawing that we just looked at, that for all intents and purposes is like a P&ID for performing the detailed cyber risk assessment. Purpose here is to rigorously evaluate the industrial automated control system. You want to make sure that your corporate risk criteria is satisfied. And in going through it, you want to confirm that what you've initially scoped out based upon recognized and generally good accepted practice is adequate or overkill. If something is overkill, then you can save a little bit of money. If something is not adequate, then you want to upgrade those countermeasures to make sure that you meet your risk criteria. just basically it's doing the same thing that you'd be doing in a traditional HAZOP. Inputs, vulnerability assessment type work that was done. If it's a new project, that's really your basic design based upon more prescriptive RegAGEP. If it's an existing plant where you're just recycling from, based upon learning things from operation and you're revalidating the risk assessment, then it would be a vulnerability assessment that would be part of the operate and maintain phase. Some of the information that you need is inputs from existing PHAs like HAZOP or LOPA. You need the configuration rules of your various countermeasures. You need to understand what kind of remote access requirements you need to contend with. Zone and conduit drawings, as I said, are like the PNID. And also want to take a look at your tolerable risk guideline that makes sure it's calibrated for cybersecurity. When it comes to process safety, chances are no changes necessary. When you look at business loss, you want to make sure that you've got some pretty good definitions so that you don't be overly conservative, okay, simply because you don't know better. Ultimately, when you go through the detailed risk assessment, you'll identify potential threat vectors. Those are pathways to achieving the intent of the attack. You'll document associated countermeasures just like you would document safeguards in a traditional HAZOP. And then you'll assess the level of risk reduction that you need based upon your estimation of what's the likelihood of successful attack given the countermeasures that we have, and also given the type of attack that it is and the kind of resources that they would need to pull off that particular attack. After we get done with the detailed risk assessment and the team feels that with the recommendations, with any potential recommendations, corporate risk criteria would be met, should be documenting the cybersecurity requirements specification. That can be done as a separate document, or you could make it a part of the safety requirement specification with a section dedicated to security countermeasure requirements. Here, long term, what we're looking for is we want to make sure that we can achieve and maintain the security level that was targeted as part of the risk review, and that needs to be for each zone and conduit. We want to make sure that the regular IACS, the regular Industrial Automated Control System functions are not compromised. Also want to make sure that the countermeasures that we have in place are able to operate among different manufacturers without degradation, so the support of interoperability is important. We do not want to degrade the safety integrity level that was determined through the functional safety analysis. We also want to make sure that we achieve our reliability targets, freedom from spurious trips, and as well as making sure that the communication speed, the response times will not be degraded that are necessary to allow the safety instrumented functions to perform. Long term, all these requirement specifications help support management of change for the life of the facility. Another good reason to have a cybersecurity requirement spec is if you're going out on a new project and it's a multi-million or billion-dollar project and you're going to an architectural and engineer, having this requirement specification is necessary to support competitive bids. Once that's done, you're turning that information over to the design and implement team. From a management perspective, there's a stage 1 cybersecurity assessment that can be performed. The way to do that, it's intended for that to be an independent check that the work was carried out. Need to ensure that the personnel that are performing that work are competent, and you want to make sure as part of it that the information that was generated was both properly documented and communicated to the folks who need that information. It's been my experience that where things go wrong oftentimes tends to be at the interface, information handoffs between one functional group and another functional group. Certainly the information that comes out of your process hazard analysis, part of which is this detailed cybersecurity risk assessment, that's a significant information handoff to the design team, most of which were probably not part of the review. So the documentation is important, the communication is important. At the end of the day, you really don't want surprises. It's there to help manage cost. You're trying to reduce future rework and scope changes that all too often occur in some of our plants. But that is the intent of all of the work that you've done before, and this is part of the quality assurance that you've actually achieved that. So in summary, we talked a little bit about integrating cybersecurity with the overall safety lifecycle. The initial foundation of your scope should be based on RAGAGEP, recognized and generally accepted good engineering practice, that should be embedded in your cybersecurity standards and procedures. If not, then some of the recommendations are to improve those. High-level cybersecurity risk assessment is by the standards required, but useful to help define your scope more crisply with a better rationale, with a little bit better insight than you would otherwise. Allows you to focus on what's important. Between the high level and the detailed cybersecurity risk assessment, you need to be looking at upgrading your design, putting together all that equivalent process safety information, and the words for cybersecurity would be vulnerability assessment inputs. Then the detailed cybersecurity risk assessment can both identify weaknesses, it can help you identify whether you have or have not satisfied your corporate risk criteria. And finally, you want to put together that cybersecurity requirement specification that's providing the vehicle to provide information transfer and support management of change. So with that, do we have any questions? Oops, hold on. Courtney, do you see any questions? I'm not seeing any questions. Hold on. I think there may have been one up here. Okay. Got somebody, may I ask about 2 points? Let me see if I can expand this. Nope. May I ask about 2 points? The assessment for lag of detection and response time, the whitelist versus the blacklist. Comment, please. Okay. Depending upon what type of attack it has is going to significantly impact just how long an attack takes to be successful. If you have a denial of service attack, I think you can appreciate that the lag time would be very little. You know, the effects of high traffic would become apparent very, very quickly, and it would impact your equipment very, very quickly. On the other hand, if I've got something where the attacker needs to understand your process, they need to probe your system to better understand the vulnerabilities that may exist in your system, they need to do this while they're not being detected. That can take months or multiple months before they can actually begin to execute an attack that would, say, cause a runaway reaction, for instance. So the lag of detection and the required response time is going to be very, very much different depending upon the specific threat vector, the specific path that the attacker is taking and what they're trying to achieve. Can't be a whole lot more specific than that at this point without looking at a specific threat vector and application. The whitelist versus the black hat. Whitelisting is a countermeasure that helps reduce the likelihood of a black hat type person gaining access. The whitelisting is gaining some degree of popularity. One of the things I've learned is having simply a single ring, believing that you have something like the Maginot Line protecting France just before World War II, that's a false premise. That's why the defense in depth, you do want a strong outer ring like your firewall, but you also want the ability to detect things once that ring has been penetrated so that you can respond prior to the attacker having maximum damage. So you can look at that as mitigating the hazard as opposed to preventing the hazard. Okay. There's another question here. Does disabling of USB ports enhance cybersecurity? If you have a standalone system, does disabling of USB ports help in cybersecurity? Okay. The answer is yes. Disabling USB ports does enhance cybersecurity. Recognize that there are, when you begin to categorize threats, you can look at external threats where it's got to come from the internet in, but you also have the potential for internal threats. And if it's an internal threat, If you've got a USB port just sitting there for anybody to plug something in while you're not looking, you're exposed. So that is just an example of one threat vector, and it doesn't improve cybersecurity across the board, but for that specific threat vector, it certainly reduces the risk. Okay. Also says here, could you elaborate a little bit more about security levels? Is there a PFD associated with security level as we have for SIL? Good question. If you look at the suite of IAC 62443 standards and the content that they have today, the answer is they have based their definition of security level on the capability of the attacker. And if you take a look at IAC 62443 3-3, they've got prescriptive requirements for various security levels based upon what they call 7 foundational requirements, things like network access and that type of thing. What 3.3 ignores are physical access, and it also ignores the human resource aspect of security. That's covered in IAC 62443 2-1, but there they don't relate those things to security levels. So that's still an evolving area. TR 840009 that I'm currently chairing, we have modified the security level definitions to include, we started out with the 62443 definition, and then we added 2 more attributes. So security level 1, we would expect an order of magnitude risk reduction. Security level 2, 2 orders, so on and so forth, and that looks analogous to safety integrity levels. We also put a time aspect, that if we have a security level 4, we'd expect that we would be able to slow things down for months as opposed to security level 3 weeks, and security level 2 days, and security level 1 hours, something to that effect. In the onion model, would each level in the model be equivalent? Let's see. In the onion model, would each level in the model be equivalent of an IPL, or would each item be listed? Tough call there. I've not seen a good onion model for cybersecurity. When I've started to look at trying to look at doing security level verification, my mind goes to putting together an event tree, because you can have different pathways. Sometimes you've got a countermeasure, but you'd have another countermeasure listed that on their own, either one of them is good enough on their own. They sort of have to work in tandem. So unfortunately, when you're looking at cybersecurity and looking at the countermeasures and the different threat vector pathways of an attack, it's a little bit more complex than what we're used to doing in a simple LOPA with IPLs. But the same concept is there. but it's a little bit more challenging to represent. That's an area that we're still working on, and hope to make some progress as we move forward. Okay. Do you feel that this PHA style approach will be incorporated into required periodic exercises? Yes, I do. To follow up with that, do you think making the assessment so analogous to a PHA would be acceptable from an OSHA standpoint? I'm not going to speak for OSHA, but I think it's probably one of the best things going today. So as I said, it's going to be an evolution. We're going to get better as time goes on. I don't think they have anything better to offer. Also, would the same 5-year cycle that PHAs are on be acceptable? It seems like with the speed of technology, 5 years could leave a facility far in the dust, and we agree with that. One of the things that I see is when you get to the operate and maintain phase, cybersecurity metrics are very, very important. And one might have the 5-year formal revalidation, but I think what you're going to see is that based upon real-time feedback, you may need to pull the trigger sooner, okay, to deal with the evolving technology. So think in terms of, the formal revalidation, that if we get to the point where you can go 5 years, great, but if we've got some 0-day things coming along, we're going to have to basically respond to those, and as part of responding to those, we're going to need to go back and look at our risk assessments to see whether we're adequate or whether there's a need to go back and revisit that as much as necessary to make sure that we continue to be where we feel we need to be from a risk assessment or a risk perspective versus the criteria of the company. Let's see what else we got here. Okay, maybe provide an example of what a threat vector. Okay, the denial of service where the network traffic greatly increased. There was a lot of trash information flowing through down to the variable frequency drive. That would be an example of a threat vector. Somebody simply taking a USB stick and somehow it got compromised with a virus or some sort of malware, general purpose malware. They stuck it into their personal computer, and now it's beginning to propagate through the network. That would be a threat vector. Another threat vector would be you've got some nation state or terrorist organization with a lot of resources. The Russians hacking into the democratic emails. That would be an example of a threat vector. If you actually had the insight into how they gained access and navigated their way through the network without detection and stole the information. Those would all be examples of threat vectors. Let's see if we got anything else, and I think I had started with that one. Okay. Next one. Okay, vulnerability assessment. What stage of the life cycle is that performed? In a new project, you're always looking at this is part of that not wanting to get left in the dust as this area evolves. Even in a new project, between the high level and the detailed level risk assessment, you're sort of doing a paper vulnerability assessment against what is best practice. You're just incorporating that into how you're designing the system. Somebody may or may not cause that a vulnerability assessment. Certainly, in the operate and maintain phase, after you've had some level of experience, as part of the revalidation exercise where you recycle back up to the detailed level risk assessment, before you do that, you want to perform a vulnerability assessment. You're going to, as part of that, you will go back and look at your network traffic. You'll go back and look at cyber incidents that may have occurred and how well you did or did not respond to those things. All of that is sort of a snapshot in time at that point, but that would be input to the revalidation of the detailed level risk assessment. If you're a brownfield site, we generally recognize that you go out and do a vulnerability assessment of what you've got for a number of reasons. One is you want to identify the vulnerabilities that may exist in your facility, but you also almost inevitably finding gaps in what I call the process safety information type of stuff. You may or may not have good zoning conduit drawings. You may or may not have a list of cyber assets, for instance. The kind of information that one would need to perform either a high level or a detailed level risk assessment. A lot of that information just isn't there in a lot of the brownfield facilities. Some of it may be, some of it may not be. So a vulnerability assessment certainly identifies those kinds of things, and that would have to be fixed up prior to performing the detailed or the revalidate, or your initial, in that case, detailed cyber risk assessment. And I think I don't see any additional questions. So I want to thank everybody. I want to thank everybody for their time, and thank you for the questions. A lot of good questions today. If you think of any questions, you can always go back and contact us through exida.com. We're also on Facebook, Twitter, YouTube, but if you've got questions, come back and feel free to send that information in, and we'll respond. So anyway, thank you, and may everybody have a great day.